Good afternoon. We are on day 8 of our Chapter 6 units, and today we're going to focus on working with parabolas in vertex form. Okay, so Roman numeral 1, let's review vertex form of a parabola. So vertex form of a parabola, f of x equals a times x minus h squared plus k. If you remember, the vertex of the parabola is h comma k, where h has the opposite sign as what you're looking at. K has the same sign. Positive a means it opens up. Negative a means it opens down. And the size of the a can give an information about the graph as well. If the absolute value of a is 1, you have what we call a medium bell, so if it's plus or minus 1. If absolute value of a is less than 1, so a fraction less than 1, it's going to have a wide bell. And if the absolute value of a is greater than 1, like 2, 3, negative 4, it's going to have a narrow bell. Another piece of information that we've talked about is the axis of symmetry. The axis of symmetry. And for an up-down parabola, which this is, the axis of symmetry is always x equals, and then the same coordinate as the vertex, in this case, x equals h. That would do your axis of symmetry. If you have to find the intercepts, meaning the x-intercepts of the graph, we've been practicing that. You set y equal to 0 and solve for x. And you can use any method that works, factoring, quadratic formula, or completing the square. Okay, so let's do an example. All right, here's an example of a parabola in standard form. Okay. We'll do an easy one first. Y equals negative 3/5 x squared minus 8. Now, this is standard form, which, if you remember, standard form is ax squared plus bx plus c. But here's the thing. If you don't have a b term, if there is no single x term, then transforming this to vertex form is very easy. It's almost a cheat. You just pull the 3/5 off of the x squared, and then you have x minus 0 squared. And there you have vertex form. This only works if you don't have a b term, but it's a nice shortcut. So on the homework, you're going to take an equation like this. You're going to put it in vertex form, and then you're going to go through what we call the data set. Some of the worksheets, the data set is written out for you, others it is not. So here's the data set. Number 1, you need to list the vertex. So in this case, it would be 0, negative 8. Number 2, axis of symmetry. And remember, it's always x equals h. So x equals 0 is the axis of symmetry for this one. Number 3, direction of opening. Sometimes it will just say direction or opening. In this case, the a is negative, so it's going to open down. Fourth piece, vertical shrink or stretch. Vertical shrink or stretch. Now when it comes to that, we're looking at comparing the graph with y equals x squared. So what we're looking for is a number out there. And just to remind you, a vertical shrink is a fraction less than 1. A vertical stretch is a number or fraction greater than 1. In the case of this one, it's 3/5, which is definitely less than 1. So we would say we have a vertical shrink of 3/5. Vertical shrink of 3/5. Okay, the fifth item on the list is the domain. Well, this is easy because all up-down graphs have a domain of negative infinity to positive infinity because they go infinitely up or infinitely down. Number 6, range. Okay, so if our graph is opening down and its vertex is up at y equals -8, it means that y equals -8 is the tallest point of the graph, and then it opens down. So our range is going to be from -infinity up to -8 inclusive because it is actually the vertex. Okay, and then the 7th item on the list are the intercepts, which you can solve any way that you see fit. For this graph, for us to do intercepts, I'm going to have to switch paper because I'm totally out of space. So you're going to set y equal to 0. That equals -3/5 x squared minus 8. And because this does not have a single x term, we can extract square roots. So I would just add 8. So 8 equals -3/5 x squared. Get rid of the -3/5 with its reciprocal, -5/3, -5/3. Now we have x squared alone equaling -40/3. And then we take a square root of both sides. And 2 x's, 1 comes out. So we have plus and minus x equals, and 40 is negative. So we have something like radical 40/3 I. We probably should rationalize this. So we're going to multiply by radical 3 over radical 3. And then I need to simplify the 40. So that gives me 3 times, let's see, 40 is 8 times 5. So 2 for the 8 times 5. Don't forget the I. And on the bottom, of course, 2 3s. So 2 3s on the bottom, 1 comes out. On the top, 2 2s, 1 comes out. And everything else is only single terms, so we just multiply 30 I on the side. So our intercepts are plus and minus. Now, here's where we get into intercepts or roots. Technically, if it's imaginary, they're not really intercepts, they're actually roots. So we'd have to say it has the roots of plus and minus 2 radical 30 over 3i. If the intercepts come out imaginary, it means there are no intercepts. We have roots to the algebraic equation, so you might want to put algebraic. The algebraic roots are there, but we have no actual intercepts. Which just means that our graph is opening downward at y 0, -8. So you've got a graph going that way. It's pretty obvious it's not going to cross the x-axis, so that shouldn't be any shock to you. So for intercepts, you would want to say there are none, but then you would say there are roots. And the roots are plus and minus 2 radical 30 over 3i. But there are no actual intercepts. So that's how you do your homework. You do not have to graph. It's just doing the data list. Okay, so we're going to do one more example. So that was the first example that we used for our data set, which is 7 items. That's on the worksheet. So we're going to do another example because we didn't actually do a more challenging problem and changing it into vertex form. So we're going to do a more challenging one. Let's do this one. F of x equals 2x squared plus 8x plus 18. Okay, so to put this into vertex form, which is your first job on your list, we need to, well, to put this in vertex form, I'm just going to change this to y. We're going to subtract the number over to the left. So y minus 18 equals 2x squared plus 8x. We do have a scalar, so we need to divide everything on the right side by 2 and park it in front. I'm going to leave a little space. Park it in front. You're left with x squared plus 4x. Leave a little space. Now we're ready to use our magic formula. B divided by 2 quantity squared. Our B is 4. So 4 divided by 2 squared is 2 squared, or 4. So we're going to add 4. Now we got to be careful though. We didn't just add 4. We just added 2 times 4, which is 8. So when we put in the balancing number, it's going to be positive 8. Okay, let's simplify. Negative 18 plus 8 is negative 10. And then we factor this trinomial into x plus 2 times x plus 2. There we go, we completed the square. Now to put this into vertex form, the y needs to be alone. So all we need to do is add 10 to both sides. And you get y equals 2 times x plus 2 squared plus 10. There is your vertex form. And we've actually been practicing completing the squares for quite some time. You might have wondered why I had you leave the 2, and then sometimes when we were solving I had you move it. The reason I left it is that in vertex form, remember that there is a number parked out front. So we can just leave it there, and just like we did, and then just move the number back over and you have vertex form. So again, if you have to solve for intercepts, you might want to go back to this form to solve. Standard form is a little easier to solve. If you solve in this form, you have to multiply out x plus 2 back into x squared plus 4x plus 4. And then you have to distribute the 2. You basically work your way all the way back to this. And then you end up factoring it or using the quadratic formula. So it's much easier for intercepts if you use this form for your intercepts. That's just a suggestion because I don't want you to do more work than you have to do. Okay, that's everything for today. Hope you took good notes. Have a great afternoon.